Optical or Hall effect encoders are usually used for closed-loop VF feedback control. These encoders measure the actual speed of motor. VFD compares actual speed and an external speed command. If actual speed is not same as command given, an error signal is generated to VFD compensator, which in return send a new command in terms of changing frequency, to remove the error in speed. Closed-loop V/F control improves speed regulation, however, it is not commonly used as it induced additional cost and complexity of system. Use of VFDs in industries. Variable frequency drives are used in almost every industry which uses motor-driven systems. Some of the uses of VFDs in different industries are discussed in following slides. VFD in cement industries. The major process in cement industry can be divided into two parts which are as following. 1. Induced draft fan for cement kiln. 2. Using conveyors to move raw material. In cement industry, limestone and clay are major raw materials, and they are to be crushed into fine powder, and then blended. In crushing and blending machines, induction motors are usually used. To operate these motors, VFDs are normally used. Furthermore, conveyors through which raw material is transferred from one part of industry to another part also uses VFD to control conveyors' speed. Variable frequency drives makes the control process more efficient. As cement making is both chemical and thermal process, air volume and mass flow must be controlled throughout the cement making process. Dampers, vanes, variable slip clutches were used to control speed of induced draft fans in past. But due to high maintenance cost and power consumption, they are replaced by VFDs. As induced fans power can be of several thousand of HP, using drives can reduces power consumption in controlling airflow. During cement making process, meeting the required condition, such as airflow, is essential. VFD effectively manages to run induced draft fans on specific RPM in such a way that it matches the required airflow. After the crushing and blending of raw materials, it needs to be transferred to other part of industry for further processing. They get used continuously, thus increase the chances of breaking them. This results in increased in operational cost. One way to minimize operational costs is to extend lifetime and availability of belt. For that it is necessary to control torque and speed required by conveyors. This can be precisely done by VFDs. By reducing the stress, not only at time of starting or stopping, but throughout the operation, on mechanical components such as gearboxes, pulley, and belts, increases the lifetime and availability of these components. To meet the production capacity, the speed of the conveyor can be varied. If production is at peak, the conveyor is run at high speed, otherwise running conveyor at slow speed save energy, thus reduces operation cost. VFD in centralized air conditioner systems. The air conditioning system comprises of refrigeration compressor, cooling medium, cooling water circulating system, cooling tower fan and coil pipe fan. The theory of fluid mechanics confirms that the output airflow of the fan is directly proportional to its speed. The output pressure is directly proportional to the square of the speed. The output power is directly proportional to the cube of the speed. The output power of the pump and fan through VFDs can be reduced by controlling their speed. Lesser the speed means less output power and vice versa. Conclusion. To conclude, with the advancement in power electronics and development in VFD technology, VFD proved to be the most energy-saving device in industries. It is estimated that up to 50% of energy can be saved. VFD as a starter, increase lifetime of motor. At time of starting, lower voltage frequency is supplied to motor so that it draws less current. Thus, VFD protects motor windings and its components from any damage due to large current. VFD also decreases the thermal and mechanical stresses on the motor, thus, increases the lifespan of components such as belt, chain, and gearbox connected with motor-driven system.